What if I told you that the past, the thing you trust more than anything, might not exist the way you think it does? Not your memories, not yesterday, not even the path you took to get here. From the moment we wake up, we trust the past as if it were a solid object, a building made of bricks and mortar, something fixed and permanent. We imagine time as a movie, one frame after another, the past recorded, the present flickering, the future not yet written. That seems obvious. You woke up, walked into this room, pressed play. Those events feel permanent, like they are etched somewhere in the universe forever. But here is the strange, unsettling truth. Modern physics, especially quantum physics, does not actually say that. In fact, one of the greatest physicists who ever lived, Richard Feynman, gave us a way of looking at reality that quietly suggests something far stranger than we can imagine. Maybe the universe does not store a single clean history at all. Maybe what we call the past is not a definitive story, but a cloud of possibilities that only seems fixed once we observe it. And once you understand this, your sense of reality will never feel the same again. Let us slow down and think the way Feynman liked to think, with curiosity, simplicity, and bold imagination. Imagine something tiny, something almost unimaginably small, like an electron. You fire this electron from one point to another, like rolling a marble across a table. Common sense, trained by centuries of observing macroscopic objects, says it should follow one path. It leaves here, travels along some smooth line, and arrives there. One particle, one path, one history. That is what we expect. That is what we assume. But when scientists actually ran experiments, they discovered something completely absurd. The electron does not behave like a marble at all. Instead, it behaves as if it travels along every possible path simultaneously. Not just a straight line, not just a simple curve, but every curve, loop, zigzag, detour, even trajectories that seem ridiculous. According to the quantum equations, it explores all of them at once, each possibility contributing to the final outcome. That sounds absurd, and Feynman himself admitted it. He famously said, "I think I can safely say that nobody understands quantum mechanics." But Feynman did not see this as a reason to despair or retreat from the mystery. On the contrary, he leaned into it, asking, what if this is not a flaw in our understanding, but a clue about the deepest workings of nature? This is where his idea of the sum over histories comes in. To calculate where a particle will end up, you do not calculate one path. You calculate all paths simultaneously. Each path contributes like a tiny wave, some waves canceling each other out, others reinforcing each other. And what survives is the outcome that you actually observe. The world you see, the position of the electron when you measure it, is the interference pattern produced by all possible histories combined. Reality does not come from a single past. It comes from the sum of many possible pasts, many potential histories. The question, which path did the particle really take, loses meaning in this context because the particle did not travel only one path. The universe did not commit to a single history until measurement imposed constraints that forced one consistent outcome. Now imagine light, because Feynman loved using light to explain quantum phenomena. Imagine shining a flashlight at a wall. How does each photon, the tiny particle of light, choose the fastest path from the source to the wall? Does it calculate the geometry like a tiny engineer, computing the shortest route with precision? No. The photon behaves as if it travels every possible path through space, straight, curved, looping, zigzagging, even taking paths that appear absurd or infinitely long. The paths that do not make sense cancel each other out through interference, and the fastest, most consistent path naturally survives. It looks as if the photon is clever, as if it knows the destination and has chosen the best route. But really it has tried everything at once, and the surviving pattern emerges from the interplay of possibilities. This is the essence of the sum over histories. Nature does not commit to one path. It allows every path to exist in superposition until measurement collapses possibilities into the reality we observe. Now step back and look at the larger picture. Everything around you, your chair, your phone, your body, your brain, is made of these same quantum particles, electrons, photons, atoms. If the building blocks of reality do not have a single definite past, why would larger objects built from these particles have one? We assume the past is solid because our everyday experiences appear smooth and continuous. But deep down, at the quantum level, reality never commits to a single fixed timeline. It allows countless potential histories to overlap, and only the ones that agree with each other survive. This leads to a startling thought. Perhaps the universe does not store the past like a recording in a cosmic archive. Perhaps all that truly exists is the present state of things. Your memories, photos, footprints, scars, even the patterns in your brain. These are all traces that exist now. From them, you reconstruct a story that you call the past. But the universe itself may not contain that story anywhere. It only contains the present arrangement of matter. Think of it as walking into a room and seeing broken glass on the floor and an open window. You immediately infer that a ball must have come through earlier, but you never actually saw the event. You are reconstructing it from the evidence you see now. In the same way, the past, as we perceive it, may be a reconstruction of the present that makes sense of the evidence, not a record etched in time. Quantum mechanics suggests that there were many ways events could have unfolded, but only one version aligns with the evidence available now. That version is the one we believe happened. The other possibilities cancel out, like interfering waves. Feynman would smile at this and shrug, saying, "Do not ask which history is the real one. Nature does not care about our stories. It only cares about what can be calculated and measured. And what we can calculate tells a profoundly strange truth. Before observation, the world is not a single fixed story. It is a superposition of many stories. Only when events consolidate into records does one coherent narrative appear." In words, the past might not exist as a fixed, permanent entity behind you. It may be something that emerges from the present. That is the unsettling part, the part that forces us to question the way we perceive reality, because it implies that time is not a rigid sequence of events, but a web of possibilities constantly collapsing into the facts we observe. The world feels solid and certain, but underneath, at the level of atoms and particles, it is dynamic, probabilistic, and fluid. Yet from this strange probabilistic foundation, our experience emerges in a stable and coherent way. That is what Feynman loved. The universe obeys rules deeper than our intuition, playful and elegant, sometimes counterintuitive, but always consistent. Even the most ordinary objects, your body, the ground beneath your feet, the light bouncing around the room, are all products of countless overlapping possibilities, narrowing into the reality you perceive. And this is not limited to electrons or photons. Every atom in your body, every spin of every particle in your brain, every photon reflecting from your eyes, followed countless possible histories before becoming part of the stable present that you experience as life. If the past were rigid, unchangeable, predetermined, life could not exist the way it does. The brain's complexity, memory, and consciousness rely on the probabilistic interactions of these tiny particles. We live in the outcome of countless quantum possibilities collapsing into consistent patterns. What we call the past is simply the story that survives this collapse, the narrative that aligns with the current evidence. And so, when you recall yesterday, you are not accessing a permanent etched timeline. You are reconstructing a narrative from the present traces that remain, a story consistent with reality as it currently exists. Each choice you make, each action, each perception, is a continuation of this ongoing collapse of probabilities into the stable world we call reality. And it gets even stranger when we consider more advanced experiments like the double-slit experiment, which Feynman loved to teach. When electrons pass through two slits, they do not behave like tiny bullets traveling in a straight line. Instead, they behave as if they pass through both slits at once, interfering with themselves like waves. And when we try to measure which slit they actually pass through, the interference pattern disappears. The very act of observation affects the outcome. The electron's history, its past path, was not determined until we observed it. In a sense, the present chooses the past. Delayed choice experiments push this even further, showing that actions we take now can influence how events appear to have unfolded in the past. It's as if the universe refuses to commit to a single past until the present demands it. And all of this, which seems paradoxical or even magical, falls neatly out of Feynman's sum over history's formalism. The mathematics is precise, the predictions are accurate, and yet the consequences are profoundly counterintuitive. We can calculate the probability of each possible history, sum over them, and find the final pattern that emerges. But we cannot say the universe chose one history until measurement enforces consistency. To continue, let us imagine for a moment that you are not just observing electrons or photons, but something much closer to home, yourself. Every decision you make, every step you take, every thought you form depends on countless microscopic events happening within your brain. Each neuron firing, each ion moving across a membrane, each quantum particle behaving probabilistically. All of these are following the same principles that govern electrons and photons. If the particles at the foundation of reality do not have a single fixed past, then your brain does not either, at least at the fundamental level. What you perceive as a smooth, linear history of thoughts and actions is an emergent story, a coherent narrative that arises from the interplay of countless quantum possibilities. It is your consciousness weaving together the threads of probability into a tapestry that feels permanent, that feels like you moving through a fixed timeline. But underneath, at the level of atoms and subatomic particles, nothing was predetermined. Everything was possible until the moment of measurement, until the physical states that define the present coalesced into patterns that we recognize as reality. This is not merely speculation. Experiments with entangled particles, delayed choice, and quantum interference show us that the past is not a fixed ledger that the universe consults. It is a flexible network of potential histories, constrained only by what we observe now. Consider this in everyday terms. You walk through a forest and see footprints in the mud. You reconstruct the past. Someone walked this way. You might even imagine the person, the shoes they wore, the direction they came from. You feel confident because the footprints provide evidence, but the footprints themselves are only the present traces. You never see the actual past moment when the person stepped here. You only infer it. In the quantum world, this reconstruction is not just inference, it is literal. The universe allows all possible events to exist as potential histories, and only the patterns that align with present observations survive to be perceived as reality. Your past, in this sense, is always reconstructed, always consistent with what exists now, but never a fixed record. And this idea can be extended even further. When you remember something, your brain is not replaying a stored recording. It is rebuilding a version of the past using present data, neural patterns, and probabilities. Memories are reconstructions, not permanent snapshots. This is exactly what quantum mechanics suggests about reality itself. The universe reconstructs histories, not stores them. Now let us take the double-slit experiment a step further and explore its implications for the past. When electrons pass through the slits, they behave as if they pass through both simultaneously, creating an interference pattern. If we try to observe which slit they went through, the pattern disappears. The act of measurement influences the past path of the particle. Delayed choice experiments extend this idea to astonishing extremes. They show that even decisions made after the particle has passed through the slits can affect the pattern, as if the universe waits to commit to a history until the last possible moment. This is not magic. This is the universe following the precise rules of quantum mechanics, rules that Feynman described in the language of path integrals, where all possibilities exist, interfere, and contribute to the outcome we observe. The past, in the quantum sense, is not a rigid sequence of events, but a network of probabilities that only solidifies when constrained by the present. Time, then, is less like a river flowing in one direction and more like a tapestry being woven in real time, threads of possibility intertwining, collapsing, and reinforcing to produce the coherent patterns we perceive as history. Think about light once more. A photon traveling from a distant star to Earth does not take one single path through space. It explores every possible route, including paths that curve through distant gravitational fields, zigzag around planets, and even loop back in ways that seem impossible. When the photon finally reaches your eye or a telescope, the observed path is simply the sum of all those possibilities interfering with each other. You see one outcome, but nature considered every potential route before deciding, through the rules of interference, which pattern would manifest. The universe does not care about linearity, convenience, or simplicity. It only cares about probabilities and their combination. And somehow, this is enough to produce the coherent reality we inhabit. The fact that we perceive continuity, causality, and a stable past is itself an emergent property of countless quantum possibilities collapsing into consistent outcomes. Reality is, in a sense, a collective illusion, a reconstruction of histories filtered through interference, patterns, probabilities, and the present evidence. And yet, despite this deep strangeness, life functions, consciousness emerges, and the world appears stable. This is the miraculous elegance that Feynman delighted in. The universe is not required to make sense to our intuition. It only needs to follow its own rules. The apparent solidity of matter, the reliability of causality, the continuity of memory, all of these arise from the interplay of quantum possibilities. The brain, for example, is a complex network of neurons, ions, and electrons. Each firing neuron depends on countless underlying events at the quantum level. None of these events need have a fixed past. And yet, together, they produce a coherent experience, thought, decision, perception, memory. Consciousness itself is a product of emergent order arising from probabilistic foundations. In this way, you are literally a story written by probability, a living narrative assembled from the interplay of countless histories that never fully existed until the present moment constrained them into coherence. This perspective changes how we think about responsibility, choice, and causality. If the past is not fixed in the deep quantum sense, then what we call decisions and actions are emergent patterns of probability. They are neither predetermined nor entirely random. They are constrained by present conditions, by interference patterns of possibility, and by the physical laws that guide the universe. The world appears deterministic at the macroscopic scale precisely because so many particles act together, so many probabilities interfere, that only a consistent pattern emerges. But at the microscopic level, the universe retains the profound flexibility of possibility. Every fact of the past that we rely on, every memory, every historical event, is actually the outcome of countless interacting possibilities that have been filtered into a coherent pattern. Reality is, therefore, less a ledger of events and more a dynamically maintained tapestry, a reconstruction that aligns with the present. Constraints. Consider the philosophical implications. If the past is a reconstruction, what does that mean for our sense of identity, our memories, our personality, our understanding of who we are all built upon what we perceive as past experience. But if the past is not fixed, then our sense of self is emergent, fluid, and probabilistic. We are not the same person as yesterday in any absolute sense. We are patterns of probability, continuously reconstructed by the universe. This does not make existence meaningless, it makes it astonishing. The fact that coherent life emerges from such flexibility is one of the deepest miracles of nature. Every memory, every sensation, every thought is both unique and contingent upon a vast web of possibilities that the universe allows to collapse into patterns that we perceive as reality. Feynman loved this interplay of the simple and the complex, the deterministic and the probabilistic, the intuitive and the counterintuitive. He showed us that the universe can be deeply playful, that reality need not obey our expectations, and yet it produces the world we experience full of order, structure, and meaning. And so the past, as we understand it, might not be a solid block of events behind us. It might be a constantly reconstructed narrative arising from the interplay of probability, interference, and measurement. The world we see, the life we live, the history we believe in, is the pattern that survives from countless potential histories interacting in subtle and beautiful ways. The universe is not cruel, capricious, or chaotic. It is precise, elegant, and endlessly creative. And in this way, Feynman's insight into the sum over histories gives us not only a glimpse into the workings of electrons, photons, and particles, but also a profound understanding of the nature of reality itself. We are participants in a universe that continually rewrites its own story, a universe in which the past, present, and future are not fixed lines, but a web of intertwined possibilities that collapse into coherence only through observation, measurement, and interaction. Every moment you live is the result of countless potential histories converging into a consistent pattern. Every memory you hold is reconstructed from evidence in the present, and every experience is a manifestation of probability made real. And perhaps this is the most astonishing, most liberating idea of all. The past is not a cage. It is not a chain that binds you. It is a living, flexible, emergent construct, created in the present from the patterns of possibility that nature allows. Feynman showed us that the universe is not merely something to observe, but something to marvel at, something far more intricate and astonishing than our intuition can grasp. Reality is strange, beautiful, and profoundly creative, and in the quantum world, the past exists only insofar as it emerges from the interplay of the present. So next time you think of yesterday as fixed, remember that the universe has been far more subtle, far more inventive, and far more astonishing than that. The past is real only because it emerges, reconstructed, and filtered through probabilities, and that in itself is a story worth marveling at. And in understanding this, we do not lose meaning, stability, or coherence. We gain a deeper appreciation for the miracle of existence, the elegance of nature, and the playful genius of a universe that is always rewriting its own history, and yet somehow allows us to witness, live, and marvel at it.